RobotMate 2025 was an educational and research workshop that included our undergraduate and graduate students from the architectural faculty and the Faculty of Applied Science and Engineering.
This year, the big change that we made was allowing the students to actually build their own robotic fabrication files. So students learned both the control of the design script and how to parse the data into the robotic fabrication script, did their own robotic simulations, have them actually build their own files to go to the KUKA robot.
Classes started with theoretical and fundamental skill development, computational design, and geometry processing using computer-aided design, CAD. And then it quickly followed by further modules on robotic fabrication and understanding how robotic arms work in the construction sector and how computer-aided manufacturing is handled.
Where students are learning like safe operations of the KUKA robot directly behind us, how to work safely in the environment, starting to kind of build our first files to run the KUKA. So learning from how our design script moves into our robotic fabrication script. So the students are learning kind of all aspects from design to fabrication in kind of a downstream environment.
Our Master of Engineering MNG students from the Department of Civil and Mineral Engineering with some specific research questions in mind were involved, where they were able to integrate their construction sequencing, structural design, and associated computational methods required for structural integrity with the rest of the workflow.
Move into about 2 to 3 days of intense fabrication of essentially building all the components that we need. And then we moved into about 1.5 days of pre-assembly and then 1 full day on site in kind of final assembly and construction of the reciprocal shell. So putting it outside of Galbraith, I think, is a really nice example of what architecture and engineering can bring together. And it becomes in a really public-facing area at the campus. It's going to get a lot of exposure. And I hope it actually has students become very interested in timber and timber tectonics. And now we can actually build very unique geometrical structures with timber. And also beginning to understand it also from the engineering side of how we actually begin to simulate and analyze these types of structures. We hope at the University of Toronto, everyone will become much more interested in progressively rethinking how we actually utilize timber.